Hey, good morning, everybody. This is Mr. Aynesworth, and we're going to get into lesson 7.2 here on inverse trig functions and go talk about how to handle those check for understanding problems. This is part two. In my previous video here, I went through the first page, basically, and that on all the learning targets in the summary. So right now, let's just go ahead and apply what we learned here about inverse trig functions and their restricted domains and apply it to some actual problems. Okay, so we're going to get right into it. Here we go. All right, evaluate each expression or explain why it's not possible. Okay, so what is the arcsine of negative root 2 over 2? What is that? Well, first of all, arcsine is another name of it, is the inverse sine of negative rad 2 over 2. All right, these are the same thing written two different ways, so we're talking about the inverse. So again, this expression right here and this expression arcsine right here, we're talking about the inverse of the function. So it's inverse notation, like we talked about the other day. So whether you say arcsine of negative root 2 over 2 or sine inverse of negative rad 2 over 2, it's the same thing. And we're talking about an angle here. This is an angle which produces a sine ratio of negative rad 2 over 2. And as you notice here above, directly above, for the inverse functions, it's restricted between negative pi halves and pi halves. So either quadrants 1 or 4. And sine is positive in quadrant 1 and it's negative in quadrant 4. So since this ratio is negative, we got to look for a quadrant 4 angle. Question, what is it? So let's go back to basics here. I'm going to draw some special right triangles up here that you need to know. Either you have the unit circle memorized or you just simply draw these right triangles here. Okay, because I told you guys you could do everything with these right triangles. You don't need the unit circle, although some people memorize it, and that's good. I don't, but that's okay. So from this triangle here, we know that the sine of 45 degrees, which is rad 2 over 2, we know that. And we know that 45 degrees is pi fourths in radians. Okay, so that's a quadrant 1 angle, our reference angle, but we're dealing with the inverse sine of negative root 2 over 2. If I asked you what the inverse sine of positive rad 2 over 2, you could respond with 45 degrees or pi fourths. But this is a negative number, negative rad 2 over 2. So it's not in quadrant 1, it's got to be quadrant 4. So what angle in quadrant 4 right here gives you the same sine ratio, okay? And so let me see. So let me draw a little picture here. Draw a picture of the unit circle. And the answer, it's got to be quadrant 4, which is down here. So we're looking at this angle here, which is 1 3/4 away around, which is commonly known as your 7 pi fourths, okay? But notice that's a positive angle. So what we want is a negative angle in quadrant 4 that has coterminal with 7 pi fourths, okay? And that, my friends, is negative pi fourths. We know that negative angles have a clockwise rotation, and that definitely is in quadrant 4. So my answer is not pi fourths, it's negative pi fourths. Again, it has to be either a quadrant 1 or 4 answer based upon the sign. And because this ratio right here is negative, okay, it's negative right here, all right, that puts you in quadrant 4, not quadrant 1. All right, and that's how you approach the first one here. Part B, what's the inverse tangent of root 3 over 3? Well, we need to go back to a different triangle right through here. So let's draw the 30, 60, 90 now somewhere. So let's draw one right here. So 30, 60, 90, 2, 1, rad 3. Okay, and on this triangle right here, we know that the tangent of 30 degrees is 1 over root 3. Now remember, 30 degrees is the same thing as pi divided by 6, all right? And that's 1 over root 3, which is rad 3 over 3. So when you see these ratios, root 3 over 3, you got to be thinking 30, 60, 90, or multiples of 30, okay? And then you just got to pick the right angle. Now tangent, inverse tangent, as looking above here, we talked about this in our summary right up here, its restriction is the same as sine. We got to go from negative pi fourths to pi fourths, so it's got to be quadrants 1 or 4. If it's negative, you're in quadrant 4. If it's positive, you're in quadrant 1. And like I said before, this ratio here is negative, so this has got to be a quadrant 4 angle. So I've got to be thinking, what angle in quadrant 4 gives me this ratio? Okay, and as I just said here, the tangent of pi 6 gives me rad 3 over 3. Well, how about negative pi 6? So this angle right through here in quadrant 4 is negative pi 6, similar to the previous one. You got to pick a quadrant 4 angle. All right, next one here in our check for understanding right here is arc cosine of 3 pi. So this is the same thing as cosine inverse of 3 pi. And we got to answer, what is that, right? So what is the restriction here? So on this one here, we're going to take the input here, the domain of the inverse function, if you look at the top of the screen, is -1 to 1. And so you can only take the inverse cosine of something between -1 and 1. So the question is this, okay, in the domain of the inverse function? And so let's analyze that right here. So we know pi is about 3.14. That tells me that 3 pi has got to be greater than 9, because 3 times 3.14 is greater than 9, which is out of the domain. Okay? And so let's say out of the domain. So 3 pi, or not out, but not in the domain. Let's say that. Okay, so it's not in the domain. So you can't take the inverse of that number there. So not in the domain of the inverse function. Okay, it's not in -1 to 1. It's not in there. Okay. Not only that, if you went to Desmos here, just for funsies, and you typed it in, so the inverse cosine of 3 pi, look what happens. Okay, it says undefined. All right, because it's not defined there, guys. It's not in the domain or in this interval from -1 to 1. So this is undefined. There we go. All right, because 3 pi is not between -1 and 1. You can't take the inverse cosine of 3 pi. All right, number 2. Let's take a look here. Determine if each is true or false. Okay, so is it true or false? Give a reason for your answer, okay? And it doesn't have to be always written or explanation. It could be using some mathematics. So is the arc sine of 5 pi 6 equal to 5 pi 6? Let's investigate. So let's take a look at the sine of 5 pi 6 first. So let's step it out. Okay, so let's do a little investigation here. What's the sine of 5 pi 6? What's that? Well, this right here is a quadrant 2 angle. 5 pi 6 is in quadrant 2, and the sine's positive there. So if I want to evaluate this, I need its reference angle. So this is equivalent to sine of pi 6. That is your reference angle. There's your quadrant 1 reference angle. It's positive, so I don't have to modify the sign, right? And then you look at your 30, 60, 90 triangle, and you ask yourself, what's the sine of that? And the sine of 30 degrees is 1/2, or the sine of pi 6 is equal to 1/2. Okay, that's step 1. So we start in the inside here, and we evaluate the first function, the interior function, and now we take the arc sine of the result, which is 1/2. So step 2, we got to take the arc sine, or the inverse sine of our ratio. And remember, this is the same as the inverse sine of 1/2. Okay, what is that? Well, 1/2 is positive, and we know that the sine, if you look at the triangle up here, let me just draw it over here. Let me draw it over again. So here's your 30, 60, 90, 2, 1, rad 3. We know that the sine of 30 degrees, which is pi 6, it gives you 1/2. We know that. So this angle right here should be pi 6. Or you can say 30 degrees is the same thing. All right, and notice right here, they're unequal, not equal. Okay, so it says, is it true or is it false? So this first one is false. All right, is the next one true or is it false? Well, let's do the same strategy here. We're going to start off with the interior function and just step it out. So what is the inverse cosine of negative rad 2 over 2? What is that? Well, let's go back up to the top. Look in the middle in the learning targets here. The The range for the inverse function has to be between 0 and pi, which means the inverse cosine of negative rad 2 over 2 has to give us an angle in either quadrants 1 or 2. And because negative rad 2 over 2 is negative, it's got to be in quadrant 2. All right. If the number you're taking the inverse cosine of is positive, you're in quadrant 1, or the angle is in quadrant 1. And if it's negative, you're in quadrant 2, because cosine's negative there. So this is a quadrant 2 angle. So I'm going to put Q2 up here just for short. All right, it's a quadrant 2 angle. So let me bring over the 45, 45, 90, our friend right here. Okay, so I'm just redrawing this so we can see the picture. We know that the cosine of 45 degrees, which is pi fourths, gives us 1 over root 2 or rationalized root 2 over 2. Okay, we know that. You guys have that probably hopefully memorized by now. All right, so that's quadrant 1 reference angle. This is not quadrant 1, it's quadrant 2. So what angle in quadrant 2 gives you a reference angle or has a reference angle of pi fourths? Well, guess what? That is 3 pi fourths. So this is 3 pi fourths. Okay, so the cosine, and you guys also know this because this is part of our mastery, cosine of 3 pi fourths here is equal to negative cosine of its reference angle, which is negative rad 2 over 2. Okay, we already know that. So I'm just reviewing. All right, so now we got to take the cosine of our answer. So the interior function is equal to 3 pi fourths, and now we got to take the cosine of it. So step 2, you got to take the cosine of 3 pi fourths, which I just illustrated over here, is equivalent to cosine of pi fourths, which is the same thing as negative rad 2 over 2, which means that these are equal. Okay, and because they're equal, the statement is true. All right, so I just analyzed each one, right? I started off with the inside function and then evaluated by the outside function. All right, these are compositions, you guys. So in compositions, you always start with the inside function and then evaluate it and then evaluate the outside function. You guys know that too. That was discussed last semester. Okay, number 3, how many values of x satisfy the equation, which is tangent of x equals negative 1? Okie dokie. So where is tangent of x equal negative 1? Okie dokie. So there's an infinite number of these guys because the tangent function, if you intersect it with the horizontal line at negative 1, intersects the x-axis an infinite number of times. So, and we know that period of tangent is pi, so what we have to do is just find one. So we know, let me start with something here. So we know that tangent of pi fourths gives you 1. All right, if you rotate in the negative direction, we know that tangent of negative pi fourths, that will give you negative 1. We plotted that on the graph actually. All right, and we know the period is pi for tangent here. So if we take an angle and add multiples of its period, we should get the same results because it's periodic. Okay, so x here could be equal to negative pi fourths. It could be, if you add pi, you get 3 pi fourths. 3 pi fourths, if you add another pi, you get 7 pi fourths. Again, I'm just adding the period here. So again, I'm adding pi, and you can keep on doing this, so go dot, dot, dot. And if you want to write it in a nice, concise way, x is, equal to negative, not negative 4, but negative pi, okay, pi fourths, plus k pi, which represents multiples of the period, where k is some integer. I talked to you guys about that in class as well. Okay, it has an infinite many, okay, there's an infinite number of solutions. Okay, how many values of x satisfy the equation tangent inverse of negative 1? Well, guess what? This is restricted, right? The inverse function is restricted. So tangent, actually, let me put this in just regular color here. So the tangent inverse, all right, is restricted. We talked about that. All right. Now let's go back to the top of the screen. So at the top and the top right, the inverse tangent is restricted, and it gives us angles only from negative pi halves to pi halves. Okay, so negative pi halves to pi halves. So how many solutions do we have? Well, guess what? We only have one. And what is it? So take a look at part A up here. So only one. What is it? It's got to be the negative angle, right? In quadrant 4, because this is a negative number here. So quadrant 4 angle, that's negative pi fourths. Okay, quadrant 4. Okay, not, okay, let me make a little caveat here. Not 7 pi fourths, 7 pi fourths, because this is a positive angle and it's not in the restricted domain. Okay, so I know that's coterminal with negative pi fourths, but you can't use that angle because it's positive and it's not in the interval. Okay, number 4, if f of theta equals cosine theta, if a comma b, which is the interval, is on, or no, point, excuse me, if this point a comma b is on the graph of f, and look at that, they switched the domain and range, b comma a is on the inverse function, which kind of makes sense. They switched the domain and range. Okay, so switch domain, okay, and range for inverses. Which of the following must be false? Okay. So is B between -1 and 1? And notice B is the first coordinate of your inverse function. So B is your first coordinate. That's it must be in the domain of the inverse. So let's go up at the top. Okay, the domain for the inverse, which function are we dealing with? We're dealing with the cosine function. So look in your, like the middle column here, okay, look at your inverse cosine function. The domain of that inverse function is from -1 to 1. Okay, and if you read the response here, B, which has to be in the domain, is between -1 and 1. So this is true. Okay, domain of f, domain of f inverse, okay, of the inverse function is -1 to 1. Okay, it's at the top of the screen. Okay, A is in your range. A is your output. Okay, so this is your output in the range. So does it have to be between 0 and pi? Well, let's take a look at it. Let's go up to the top. Well, look at that. Yes, the inverse cosine function is restricted between 0 and pi. All right, so this is true. All right, so the range here, all right, is 0 to pi inclusively. Okay, next one, C, is b comma a plus 2 pi. Is it also on the graph of the inverse function? Okay, so if you take, now remember the range right here has to be from 0 to pi, and if you add pi to 2 pi to something, that's going to be out of the range. Okay, so this one's false. Okay, because the inverse function, f inverse, all right, is restricted. All right, from 0 to pi. All right, and if you add 2 pi to the range, you're going to be out of the interval. So this is false. And then here, negative a comma b is also on the graph of f. So notice that we took the opposite of the coordinate here. So why is this true? This is true. But why? That's because the cosine function, all right, is an even function. All right, what does that mean? That means it has y-axis symmetry. Y-axis symmetry. If you don't believe me, let's just draw a graph. Okay, so here's cosine. So if you're going to draw the cosine function, it goes like this. But you can also do it the other way. And if a comma b is on the graph, so let's say this is a comma b, and then if you go straight across, guess what? The opposite of a comma b is also on the graph. This is called an even function, and it has y-axis symmetry. Okay, that's what I was talking about just a minute ago. Okay, so that one's true. So the only one that's false is part C. All right, there you go, you guys. That's your check for understanding in lesson 7.2. Hopefully that helped you out. And if you need some more help, I'll see you in class. Take care.